This afternoon to dynamic models in Django. Some quick words about me. I'm working with Python and Django for about 4 years. Unfortunately, most of this time just as a private fun. Luckily, since about 3 months, I'm working for Reliatech. We're building Django web applications, and we have a special focus on EDC systems for clinical studies and telemonitoring systems. And let's see what kind of Django stack we will get in there. But today, I would like to talk about dynamic models. So, objective today is I would like to discuss with you why do we even care about dynamic models in Django? Why we have to talk about them, and possibly what we should or could do about them. So, what is the problem? The classical approach in a Django project is that you start with the code development, which basically also means that you define your models and your model attributes with Python code by implementing it in your models PY. Then you deploy your project, basically running syncdb next to some other stuff, of course, which then creates the underlying tables and columns that you require. And finally, at the runtime, your models and database tables are populated with content as part of the normal user interactions. So that's how it is. We have reached version 1.5. You might wonder, well, is there a problem? I think there is, because at the moment, the Django models are defined during implementation. And by definition, they are expected to be static after deployment. Problem here is that there's no way to adapt your Django models and your schema at runtime based on some user interactions or based on some user input. Now, there are possible solutions for that out there already, like database-specific solutions like HStore that we've learned yesterday on Wednesday. And there are also no SQL databases, but unfortunately those are at the moment not fully supported by the standard Django database backends. So I think there is a problem, but is the problem relevant? So let's discuss some use cases and see if we really have a relevant or serious problem. First, and I think that the classical use case, a content management system, I've taken some screenshots here from a Java-based system called .cms. We have a content type that is called promotion, that has a title, a link, a teaser, and an image. And suddenly, the marketing guy decides he needs a promotion end date there. And there are two options now. Either, like we see here, he goes into his usual browser and just says, I need another field that is called promotion end date. If you would like to do that with Django today, that means that your marketing person needs to go to the developer, and the developer then needs to implement it and redeploy the project. Other use case, customized products for an e-commerce shop. Here we have screenshots from the Magento shop, which is PHP based. Of course, you have all kind of different products, and there's no chance that you can anticipate all kind of product types. And again, you would like to have a promotion end date here. Here the product manager just says, okay, give me this field and it will be available. And it can be used and reused. And finally, and this is the area where I'm coming from at the moment, we have clinical research forms that are defined by researchers or doctors. And those research forms depend on all kind of stuff. They depend on the drug that is investigated. They possibly depend on the country and the location where the study is executed. And it is necessary that those things can be defined within the system. And with those clinical research systems, there are very special requirements in terms of security, testing, and system validation. And there is definitely no way that for each new field that some doctor wants to see here and wants to apply, you deploy code and test it and put it on production and validate the system. Because we're talking here about a process that might take weeks and months, and that needs to be certified. So you can't run a certification process over the system just because a doctor wants to have a new field with the age of the person or whatever. So at the moment, these kind of use cases are not really realistic with a classical Django project. Well, problem. Some people of you might now say, that's not a problem, that's what I make my living from. Customers come to me and ask me to change something in the system, and that's good that way. Which, yeah, I can understand that, but I think it's not exactly the complete picture. Because models or content types are always domain or site-specific or specific to your customers. And it's in general not realistic nor efficient to implement all possibly thinkable content types. And I, in general, think that configuration of a system by subject matter experts is better than code customization by developers. And I think realistically, when we think what are fun projects for us, what is fun work for us, usually it's not adding some new fields to already existing models because a product manager has some new ideas and tomorrow he has the next idea, and at the end of the day you have discussions with the IT department if somebody has budgeted for that work, because usually not. IT usually says marketing has a big budget, talk to them, and marketing then says, yeah, but that's IT, I won't pay for it. So that's all, it's no fun work, no fun discussions, a lot of political trouble there. And finally, with dynamic models, you would be able to reduce the number of deployment cycles, because today each change to a model will require deployment. And as I described with certain kind of systems like, in clinical research, this is completely not realistic. So I think we have a problem and we have a relevant problem. So let's see what we can do about it. Let me review some typical patterns that are available to solve those kind of problems. What kind of apps are already available there in the Django ecosystem. And let's try to evaluate those. So what are requirements? As a user of the final system, I would like to be able to maintain those dynamic models easily without understanding anything of the Django backend or anything about Django models or whatsoever. I would like to extend existing static models or create new ones without thinking about what is now static, what is dynamic. Could that possibly affect the performance of my system? One problem, for example, of the Magento shop that I presented before was, or is, that with increasing number of fields or increasing number of products in the tables, the performance will certainly get an issue. This is not a really nice situation if I'm a product manager. I just want to get things done. Or with the .cms content management system, you're limited to 25 fields in a dynamic model, which is okay for most of the use cases, but still a limitation that is kind of annoying. And when I query or search for some specific data, I don't want to care if the data is in the static parts or dynamic parts of my project. From a developer point of view, I would like my dynamic models to be integrated with the Django standard tools and toolbox like the admin, like migrations, like reversion out of the box. So if possible, I would like to use the same logic and of course the same API as for my normal static models. And I do not want to be limited to specific databases, but want to be open to all the standard Django backends. And this is really a challenge, as I will show you later on. I would like to have a customizable front end for my users that enables them to manage the dynamic models easily. So that should be somehow built in already. For this talk, I would like to focus on the following 6 criteria to evaluate the patterns and apps. First one is performance. I would like to have a kind of stable performance. I would like to have a queryability, and I mean here the standard API should work, and I should be able to work with the models and model data the same way as with the standard static models. Django standard tools should be working. I would like to work with a supported backend, and the complexity or added maintainability overhead should be as little as possible. The first pattern is the so-called entity attribute values. And basically what you're doing here is that you transform your table columns into table rows. And as you can see here, basically instead of having one table, you will have 2. One is basically the container, and the second one is the attribute table that contains attribute name and attribute value pairs. This is nothing specific to Django. The entity attribute values is a standard pattern, but we have 2 apps that have implemented those. And to me, they look quite stable. The projects don't seem to be overly active, but they seem to be quite usable to me. So if you want, I think you can use those. The major downsides with the AAV models is that the performance goes down, because if you look at the right-hand side of that slide, if you run any queries over those, you can imagine that this is more costful, and at a certain point in time, you will run into some performance issues if you have huge amounts of data or if you have a huge amount of attributes in your tables. Second approach are serialized dictionaries, which basically means you transform your table columns into pickle.json dictionaries. I think the approach is straightforward. There are a couple of Django apps or fields that support these. There are basically those for field applications or apps that provide custom fields. And there are much more. I think those are the most popular ones that I found. And there's also one app called Django Dynamic Model that does not only provide fields, but really provide a custom model class that takes care of a lot of things. General problem here is that you move a lot of the work and logic that is usually done on the database level into the application level, which is probably not the best thing for performance, and which also means that you probably need to build, you mostly need to build some custom logic into your application level to take care of that. The third pattern is what I call runtime schema updates, which basically means that you update your Django models and the database schema at runtime based on some user interaction. And you can either use syncdb functionality that is already built in Django, or use or reuse some south functionality. And eventually, you might also be able to use Andrew Godwin's schema migrations for Django. And there are actually a couple of applications that support that. The very first one was from Michael Hall, which was using syncdb functionality. And then Will Hardy has developed dynamic models and Django Dymo. which was the first one that used South. Following his comments, and I think he already gave a presentation some time ago, about I think 2 or 3 years ago, this approach seems to be quite stable and working well. And I actually liked the approach so much and had a lot of ideas that I could do differently, or I thought I would do them better. So I created Django Dynamo with a lot of reuse of the concepts that Will Hardy has already developed. But basically, Michael Hall's approach, Will Hardy's and mine, or the applications are more prototypes or proof of concepts. And Simon Charette then thought, yeah, great, but I can even do it better. And he created Django Mutant. And from my point of view, this is the most mature application there at the moment. He's actively working on it. I would say this has reached some kind of beta status, and I think he's using it for some projects. Yeah, he's also waiting for schema migrations integrated into Django, because then he would like to migrate to the schema migrations. Yeah. So this is the schema update. In general, I think those is the most powerful one, coming with some downsides that I will explain in some more detail later on. Yeah, we have database-specific solutions like HStore or NoSQL, but I think there are certainly problems where this is the right solution. But from a Django community point of view, I think we should have solutions for that problem that is not database specific, but works with all implemented and supported Django database backends. Summary, from performance point of view, EAV definitely is a problem. If your models are not too complex, or if you don't have that much data, I think they are fine. But yeah, there will always be significant overhead. Serialization approach is working fine as long as you don't put too much logic into the application layer. Schema updates basically work exactly the same as the static models, so we're fine here. In terms of peerability, the two EAV applications are quite fine. They abstract most of the things away from the developer. With the serialization approach, you probably always need to do some specific stuff on the application level. So this can be done, but it requires extra work. With the schema updates, we're fine here again. Integration into the standard tools, EAV should be fine there. It comes with the custom model classes and with the custom admin. The serialization, if you use the application, it also comes with their own admin and their own classes, model classes. If you use only the JSON or pickled fields, yeah, the integration won't work that well, realistically. Schema updates, yeah, no difference to static models. All three support all the backends, so we're fine there. With regard to complexity and maintainability, EAV is, I think, straightforward. The additional database tables and so on are created in the background. You don't have to worry about them. Serialization is a little bit more, because you will usually be forced to add some logic into the application level. However, with the schema updates, I am afraid that complexity overhead is significant. Just to name a few, I'm not sure if this is the complete list yet. There might be name clashes between developer models and dynamic models, especially when you think about schema migrations. There might be multiple users updating the same model, possibly with conflicting data. You might end up with orphan database elements. You have to make sure that your dynamic models are loaded at startup time before any other logic kicks in. And also you have to find ways to find and inject dynamic models into your views and templates. All those problems that I mentioned here are solvable. That's not rocket science, but that's definitely something you have to have in mind when you think about the schema update approach, because otherwise you might easily end up in major trouble. But from my personal point of view, the schema update approach is by far the most powerful one, the most stable one. We just have to make sure that we solve these problems and possibly some more that might come up. Finally, I would like to give you a short overview or some of my ideas, what kind of components should be part of a dynamic model app. First of all, we need a front end where the users can maintain their data on the meta models. We need to have a representation on the back end to store those meta model data. Of course, this will be a classical static model. We need an analyzer that detects the changes and then triggers specific actions. And those actions will be taken care of by the schema sync manager, which will update the database schema, by the admin sync manager, which will update the Django admin, and by the model and cache sync manager, which will update the Django model classes and model cache. I think the applications that I've shown with meet most of those or represent most of those components already, better or not that good. But I think that the biggest challenge is to build a front end that the users can use easily, that reflects all the possibilities and complexities that you can build into your Django models and Django fields. And I think that's also one of the remaining challenges that Simon Charette has in his Django Mutant. But I had some email contact with him, and he told me he's working on it, and at least he will provide some examples how to do that. If you want to read a little bit more on dynamic models, these are three very good sources, so have a look at those if you want to get into it. Thank you very much. I'm looking forward to interesting questions, some more problems with the approach. Yeah, thank you.